Hi cohort, this is one of this week's statistics videos on one of the topics we covered last Sunday in our class, the two sample t-test. So I have a couple of slides here in case you find them helpful. All right. And here we go. So the first thing you want to do when running a two sample t-test, and again when we would do this was when we had two population means that we were trying to compare. And so there is a step one, if you're wondering, well, why is this step two? It's the first slide. There is step one, but we're not talking about it in our class. There are certain assumptions you have to make about your data in order to run a two-sample t-test, but because we're not covering it in our class, I'm not going to worry about it. Okay, so your null hypothesis is always that the means are the same. In other words, if you subtract them, you would get zero. So the null hypothesis is always the same. The alternative hypothesis is going to be one of these. You would do the first one, a two-sided test, if your question was, are the means different? You would do the second one, a one-sided test, if you thought the second one was bigger than the first. And you would do the third one, a one-sided test, the other direction, if you thought the first was bigger than the second. Don't worry, we'll do some examples. The test statistic is really gross, and so really I hope by now you guys have gotten technology that's going to compute this test statistic and p-value for you. You kind of saw in class that one little slip up and the whole thing is wrong, so it's best just to enter your data and let technology do the arithmetic. Again, you're going to get a p-value, and so once you get your p-value, you'll get your conclusion. Remember that smaller p-values give stronger evidence against the null hypothesis and in support of your alternative. Okay, so we'll come back to this confidence interval in a second. Let's go ahead and try a homework problem. All right, so this is number 8 from chapter 14, homework. And it takes a look at the familiarity with assessment increased test scores. So they had two groups of students, and notice they're two different groups of students. That's why this is a two-sample t-test, not the second thing we talked about, which is matched pairs. These are just 11 students. They put 6 in one group, 6 in the other group. They're not paired or matched in any way. One group, they gave an overview of the test before they did the assessment, and the second one had no overview. This is kind of like going for an interview and whether they give you the questions in advance or you don't. So that's kind of the idea behind this. Okay, so the first thing, and the question is, blah, 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 blah. Okay. So does familiarity with the assessment increase test scores? You hypothesize that it does. So we're not just asking does it make a difference. We really want to know, did test scores increase? Alright, so let's get started without our null hypothesis and our alternative hypothesis, because that's our first step. Okay, so let me just open up a Word document and we'll get going here. Alright, so your null hypothesis. Whatever group you want to make the first group is really up to you. So a lot of times people just do it in the order it's given. So the first group is the overview group. So we're going to say the mean of the overview group is the same as the mean of the no overview group. And you can label this mu1 and mu2. So we could be writing, for example, mu1 equals mu2. Or you could write mu1 minus mu2 equals 0. They mean the same thing. So let's write our alternative. We're wondering if the overview increases test scores. In other words, we want to figure out if the mean of the overview is greater than the mean of the no overview. And that's our alternative. So in other words, mu1 is greater than mu2. Or, if you write it with the 0 thing, you would write mu1 minus mu2 is greater than 0. Alright, so now I know and our alternative hypothesis are written. The next thing we want to do in hypothesis testing is we want to compute a test statistic. So remember, we want to do that using technology. So I'm going to move this. I'm going to look at that. Close that. Okay. Alright, and I'm going to try to access my calculator. So my calculator is up here. So what I'm going to do once I get my calculator going is I'm going to put the data into my calculator. So I'm going to turn my calculator on, come here to statistics, and again, if you're having trouble using whatever technology you've chosen to use, just let me know and I can hopefully help you out. So right now I'm going to put the numbers for the overview group into one list. So 20, 18, 14, 22, 16, and 16. Great. Okay, and now I'm going to put in the data for the no overview list. 11, 15, 16, 13, and 9. Great. So the data is in the calculator, we're just going to run our test. So I'm going to come here to the test we're looking for, and the test we're looking for is a 2-sample t-test. I have data in my calculator. The first is in list 1, the second is in list 2. You just leave the frequencies at 1. Now when you come down here, they want the sign in the alternative hypothesis. So just as a reminder, here's our alternative hypothesis right here. We have a greater than sign. So I'm going to come over here and I'm going to highlight the greater than sign. For pooled, Dr. Jen just said leave it at yes. What we're saying is we are assuming that the standard deviations for those two distributions are not significantly different, and that's usually a safe bet. You can calculate or draw, or do whatever your technology does. And so here it's drawing a t distribution. And on the bottom it's going to give us our test statistic and our p-value. So at the bottom we see our test statistic is 2.76. And the p-value is 0.011. You can see right out here, there's just a tiny bit of shading, so we know our p-value is small. I'm going to write this down because I think this problem had an unusual alpha that they gave us. So our test statistic is 2.76, so we're over 2 hops away, but not quite 3. And our p-value is 0.011. Okay, so if I come back here to this problem, oh bummer, how'd that come blue? All right, it says we're going to use a significance level of 0.01. If you notice, this is just slightly bigger than 0.01. So we're not going to reject our HO. Don't reject the null hypothesis. There's not enough evidence to conclude. The overview increased scores. Alright, that's all there is to a 2-sample t-test if you've used technology, so let me know if you have any questions and hopefully this was helpful.